Women!
Hey, my name's Henry. I'm going to be showing you how to do the W double distribute method. So we're going to start with 3x to the second plus 2y to the third power. So normally you would, if it was to the second, you would just FOIL. You would just FOIL it, and we will end up doing that just a little differently. So you write it out like this: 3x to the second plus 2y times quantity 3x to the second plus 2y, and so on. So you write it out like this, shown, and then from here you carry out just two of the binomials. So usually, easiest to do the last two. You carry out the last two, and then from there, what you do is you get 9x plus 2y plus 12xy plus 4y to the second. You get that, and what you do is you bring down this other binomial right here, as shown here. You bring it down here, and then you carry out each term. So as shown here, 3x here, here, and then you do the 2y, and then from there you write it like this. So you write everything you carry out from the 3x on top, and everything you carry out from the 2y on the bottom, and you match up the like terms. Example 36 x to the second y, and then 18x to the second y, and you match it up like terms, and then that is how you get your final answer. 27x to the second plus 54x to the second y plus 36x y to the second plus 8 cubed. That's how you 8y cubed. That's how you get your
1. Have you ever found yourself needing help expanding using Pascal's triangle and binomial expansion? Well, today I'm going to help you. I'm going to use a problem from Mr. Suhu's practice test. And on the black market, this practice test is worth at least $100. It's quite amazing. Anyway, the problem that we're going to use is parentheses 3x plus 2y close parentheses to the third. And the way you're going to start off is using Pascal's triangle. And for those who don't know, Pascal's triangle looks like this: 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. See, these are just the first 4 rows, but this Pascal's triangle goes on forever, and it goes till however many rows you need it to go to. And the way it's formed is you just add every number in a row together, and it equals a bottom number, a row in the bottom row. See, so 1 plus 1 equals 2, so on and so forth. You get the gist of it. So the way you're going to see which row you need is by the exponent in your problem. So if you see that it's 3 here, then you're going to be using the third row. And you will be going like this, and so you'll be 1 plus, plus, and plus, and you are going to get 3x and 2y in each other in parentheses, and the x is going to start at the highest number of exponent, and then y will start at the lowest. So it will go 3 and 0, and it will gradually go up until you get to y being the highest exponent, and then x being the lowest, x being 0, and then y being whatever it is, and in this case it will be 3. So I've already done that in the back of this. It's a little messed up, but it's fine. So as you can see, let me just quickly write this a little quick, just right over these smudges. Anyway, so as you can see, I separated it from 3x, 2y to the third, and 2y to the 0, continuously on, till I got to here, which all I need to do now is add, and I'll get the answer that I need. For those who don't know, if you can tell that if 2y to the 0, it equals 1, and that's in any case. You can have 1,000 to the 0, and it will equal 1. Anyway, so how you're starting here is you're going to do your binomial expansion, and you're just going to simplify to these points 1 to the times 27x to the third times 1 plus 3 times 9x2 times 2x plus 2y, plus 3 times 3x times 4y to the second plus 1 times 8y to the third. And that continues in going on here. It was the same way, except these are both the same thing. And after that, you just simplify even more till you get, that's not a 3. Till you get 27x3 plus 54x2y plus 30x y2 plus 8y3. As you can see, it goes from x3. As you can see, y, this right here is y0, and it, as you can see, it shows from here. Anyway, so that's your answer. Your answer is 27, not 2xx. 27 to the third plus 54 to this 54x to the second y plus 30x y to the second plus 8y third. And that's it. That's now you know how to expand using Pascal's triangle and binomial expansion. Bye.
We start off with the equation 5x to the third minus 20x to the second minus 45x plus 180. And the first thing we do is find the greatest common factor, which is 5. And we divide that out of each. And once we get that, we get the equation 5 times, in parentheses, x to the third minus 4x squared minus 9x plus 36. And after that, you actually have to separate the equation into two groups, and the two groups are x to the third minus 4x squared plus negative 9x plus 36. And once you have that, you actually have to find the greatest common factor yet again of the two. And for the first equation, x to the third minus 4x squared, it's x squared. And for the second one, negative 9x plus 36, it is negative 9. And you get x squared times x minus 4 plus negative 9 times x minus 4. And once you get that, you actually take the two factors that you factored out of both the grouping equations, and you actually plug those into a formula for your final answer. And then you also take x minus 4 and put that in the equation too. And after you have x squared minus 9, you have to do the difference of two squares method. And you get x plus 3, x minus 3 after you use that. And then you plug in for the final equation 5 times x plus 3 times x minus 3 times x minus 4, which you get from the above equation.
Alright, so this is find all real solutions using synthetic division given one possible solution of f of negative 3 f of x equals x to the third minus 5x to the second minus 9x plus 45. So this is what you get, and you're using synthetic division. Alright, so what you do is you pull out all the coefficients, 1, negative 5, negative 9, 45, and then from there you draw this little box here, like a little box. You pull the 1 down. So this is how this works. So you do this times this. So negative 3 times 1 is negative 3. You put that here, then you add, so negative 8, and then negative 3 times negative 8, and then you get 24, and then you add, you get 15, and you do that for the last one, you get 0. So then what you do is you take those numbers here and you put it into standard form. From standard form, then you get you have to make it equal to 0. So x equals -3, and then you have to get it x plus 3 equals 0. So x plus 3 times quantity x to the second minus 8x plus 15, and then you do something called double happiness method. So it's just like factoring. So with that, you pull out x. So you pull out x and x from here, and then you pull out 3 and 5 from here, and then you write it in this form: x plus 3 times quantity x minus 3 times quantity x minus 5 equals 0. And then these are your those are your answers. Those are the solutions. X equals -3, x equals 3, x equals 5. Thanks.
Hello, it's me again, Eric Suarez. Now I'm going to help you trying to write a polynomial equation in factored and standard form. And in this problem from Mr. Suhu's $100 guide, we're going to use the plot of a roller coaster. And the x-intercepts in this are x equals 0, x equals -4, and x equals 4. So the first thing we're going to do is try to make each x-intercept into 0. So x already equals 0 in the first one. Then we will have this plus 4 plus 4. So x plus 4 equals 0. Minus 4 minus 4. So x minus 4 equals 0. Okay? Then we are going to put that in a factored form. And in factored form, this will look like y equals x, 4 plus 4, and x minus 4. I'm sorry for that. It's x plus 4. I'm sorry. Anyway, and that's already if all you need to do is factored form, you're done. That's factored form right there. But if also you need to put it in standard form, then what you're going to do is use the double distribute method. So let me just erase this box here. Okay? So what you're going to do is you're going to get y. Let me rewrite it because it got a little erased here. Y equals x plus 4 and x minus 4. What you're going to do is use the double distribute method. You could also use the FOIL method, I believe, but the double distribute method is the best way to go. So what you're going to do is do 4 times x and 4 times -4 and x times x and x times -4. And out of that, you're going to get x2 minus 4x plus 4x minus 16 parentheses. And then you're going to simplify. And since there's -4x plus 4x, x is completely canceled out, and it equals x times x2 minus 16. And from that, you're going to then distribute x onto these two, which will equal y equals x3 minus 16x, and that's standard form. Okay? If you get this and you graph it, it will have the same x-intercepts as this. So your roller coaster will actually look something like this. See, I've made the graph already right here for you. -4, 0, 0, and 4 right here, x-intercepts. That's what your roller coaster would look like, and your graph would look like. Then, now, we're going to classify the polynomial and find the degree and leading coefficient. We will also then find the graphed interceptions and x-intercepts. And then there's also how many turning points. Now I'm going to teach you how to classify the polynomial. So this polynomial is a cubic binomial. And the way you figure this out is the standard form of this polynomial. which is y equals x to the third minus 16x. And the way you find the cubic part, the first part, is the degree, or the highest exponent, which is 3. So that's why it was cubic. And then, the way you find the second part is by the number of terms. So if it's 3 terms, it'll be a trinomial. But since this is only 2 terms, it's a binomial. So that's how you find out that it's a cubic binomial. And now, we need to find the degree and the leading coefficient. And the way we find it is just from when you write y equals x3 minus 16. It's all here. So if the degree is the highest exponent, which is 3, so it's odd. So we have an odd degree of 3, and then the leading coefficient is the number of the degree. Well, the number that is next to the x of the degree, which is 1 basically here, which is 1 because, yeah, it's 1. Which makes it a positive. So the leading coefficient is positive because it's not negative. 1 is positive. So that's how you find out your degree and leading coefficient. Now, I will teach you the way to find the graphs, interceptions, the x-intercepts, and the number of turning points. And the way we're going to do that is using the standard form of this polynomial, which is x3. And the way you find the number of turns is the degree. And it's the degree minus 1. So since the degree in this polynomial is 3, and 3 minus 1 is 2, this will have 2 turns. So it will have 2 turns. And the graph of this will look somewhat like that, because the degree is odd and the leading coefficient is positive. Now, to find the graph interceptions, we use the leading coefficient. Well, we use the graph here. We use the graph. As you can see, that left an x minus is an x minus infinity, and down y minus infinity as well. And then here is right x plus infinity, and up, y plus infinity. That's how you find the graphing interceptions, which is easy. It just depends on how the graph looks. Next, we find the x-intercepts. And the x-intercepts were already given to us. We've already seen them. And they're just 0, 0, negative 4, 0, and 4, 0, like I showed you on the graph before. And that is how you find the polynomial in factored form, standard form, the way you classify the polynomial, finding the degree, finding the leading coefficient, and getting the graph's interceptions, the x-intercepts, and how many turning points there are. Goodbye.